26 of Python Pro from CTC. Today we are diving into stacks in Python. So what is a stack? A stack is a collection of elements with two principal operations. Push, which adds element to the collection, and pop, which removes the most recently added element. A stack is simple yet powerful data structure that follows the last in first out principle, the LIFO principle. Imagine a stack of plates at a cafe. The last plate added is the first one to be taken off. Stacks operate in a similar way, making them incredibly useful to various programming scenarios. The last element added is the first one to be removed, creating a neat and orderly structure. See how stacks actually work. Think of stacks as a vertical arrangement of elements. When you push an element onto the stack, it goes to the top. When you pop an element, it comes off the top. This dynamic behavior is particularly useful in solving problems that involve a last in and first out processing order. For examples, evaluating expressions in programs. Stacks play a crucial role in evaluating arithmetic expression. For example, if we are trying to add 5 plus 2, those operators and operands are added to the stack, then they are evaluated. Then there is undo mechanisms. Whatever app we use, for example, PowerPoint, Word, Excel, everywhere we have got undo operations where we are going to use the LIFO principle, last and first out principle. So those undo mechanisms use stack. Also, browsers. When we are using a browser, we are using the back button and the front button as much as we want, right? Those operations also use stack. Let's see the basic operations in a stack. So push and pop has a time complexity of O of 1 and search element by value has O of n. Let's see how push and pop works. So this is a stack, an empty stack. We are adding 5 in it. So it goes to the bottom of the stack. Then we add 4, it goes on top. Then 6, it again goes on top. Then 8, it again goes on top. So the topmost element is called the top. Again, if we are popping, the first added element won't be coming out first. That is, the 5 won't be coming out first, but the latest element, the recently added element, will be coming out. So if we pop, 8 will be coming out, then 6 will be coming out, then 4, and then 5, then we will get an empty stack. Here is the coding implementation of stack in Python. In Python, we are going to use a list to implement stack. So here we have initiated a list. Then we assign top equal to none because we have got an empty stack, right? So while true, we are going to print these things. If choice equal to 1, push, pop, peek means we will seek out, we will see the topmost element. That is what peek means. Then display will display the whole thing, whole stack. Then we got exit. This will loop till we exit. So let's see how this actually works. So empty, we are checking if the stack is empty or not. If the stack is empty, it will return true. If it is not, it will return false. So again, we are going to push. To push, we are going to use append function, stack.append of the element. So we are passing 2 arguments here instead of 1 as we saw an empty. We are just going to pass the stack here. Here we are going to pass the stack along with the element. So append of the element, then we will assign top as the last index of the list. Then pop. To pop, there has to be something in the stack, right? If there is nothing, we can't pop. So if we are checking if the stack is empty, if we empty of stack, it will return true or false. If it's true, then it will just return underflow. If it is not, okay, there are two concepts in stack. If we are adding an element over the limit of the stack, it will return overflow. And if we are trying to pop an element when there is no element, it will return underflow. So if the stack is empty and we are trying to pop, it will of course return underflow. Then else if it is not underflow, then we will just remove the element. Then if the length is 0 by now, for example, if we are removing the last element, the length will be 0, right? In that case, we will assign top as none because there is nothing in the stack. But if not, we will just assign top equal to len of stack minus 1 so that the top would indicate the last element. Then we will just return I, because the pop function should always print the element which is removed from the stack. Then peek. If it will check again if the stack is empty. If the stack is empty, it will return underflow. If not, we will take the last element as top, then we will just return the top. Then display. We will check again if the stack is empty. If it is empty, we will just print the stack is empty. If not, we will, as always, assign top equal to ln of stack minus 1. Then we will just print the top element. Then we will go in the reverse order and then print this elements of the stacks one by one. Okay, we will just change this. Let's see how this works. So implementations in stack: push, pop, peek, display, and exit. We have got an empty stack now, so we will just push something. 1, enter item 23. Again we will just push an item 48. Again we will just push an item 18. Now 4 is display, right? We will just try to display everything. It should print in the order of 89, then 48, then 23. So 89, then 48, then 23. What if we are trying to peek the element, peek the stack? We should get 89. The topmost item is 89. What if we are trying to pop an element? Okay, we have popped 89. We are again popping 48 should be popped. Now 23 should be popped. 23 is popped. Now what if we are trying to pop? It returns stack empty. So now we can just exit the whole. Yeah, we have exited it. So after in this loop, we will be getting the returned value from these functions. We are assigning if the choice equal to 1, will push in the stack along with the item. We are calling the function push here. If it is pop, we will check I equal to pop of string, so that we can just store the returned value in the variable I. If I is underflow, then we will just print stack is empty. If it is not, then we will print the popped value. Choice 3, we are going to peek. We are again storing the peek function in a variable, so that we will know if it is an underflow. If it's underflow, we will print stack empty. If not, we will just print the topmost item is I. In display, we have already printed everything here. In display, we have already printed everything here, so we don't have to return anything. Again, in choice 5, it is just exit, right? So we will just break. You will just use a break statement to break out of the loop. Else we will print invalid choice, so that it will loop again and again till we give a valid choice. Then we will exit. A function to reverse a string. Here we have got a string. We are going to use the reverse function we have just created. So the reverse function will initiate a stack. Then what we will do is we will just push everything into the stack one by one from the character, from the string. So we have got a variable called reverse string here, which is empty. While the length of stack is not equal to 0, we are just going to pop everything. That is, as we know, if we are going to pop an element, it is going to be printed, right? It is going to be stored in some place. So reverse string will be, in the reverse string, we will be adding the popped element one by one using this while loop. So in this, it will be stored as Q, then E, then W, then E, then R, then T, then Y, right? It will be added as Y, then T, then R, then E, then W, then Q. So we are just returning it. Let's see how this works. We got the answer as a reverse string. So let's see a different approach here. We are getting input from the user itself. So let's try crescent. Yeah, we got the reverse string. Why this is a optimized or efficient program, instead of we can just reverse the whole string just by slicing the values of the string. But as you can see, as I have learned, the pop and push functions in stack has a time complexity of O of 1. So using a stack to reverse a string is much more efficient. Thank you.